everyone. Today we're going to be talking about how to solve equations when there are variables on both sides of the equal sign. So just like when we're solving equations when there's a variable on only one side, my first priority really is to simplify whatever it is I'm looking at. So my first step is going to be to distribute to get rid of any parentheses. Now, remember from last week and from talking about solving with variables only on one side, that if I don't have any parentheses, or if at any point I get to a step that I don't need to do, I can just simply skip over it. So if I'm looking at this first example, the first thing I want to do is distribute through those parentheses. Now, this one's a little tricky because the parentheses and the distributing happen in weird places. So here's my parentheses, and here's the number that's directly outside. That's what's important when I'm distributing. This 5x is not part of my distribution, so 5x is just going to come down. Okay. Then I'm going to distribute. In the front is technically a -1. Okay, so even though that looks like it's just a minus sign, really that's a -1 out there. So I'm going to treat that the same as I would treat any other number. So -1 times x. -1 times x is -1x. -1 times -18 is +18. Make sure you're being really careful with your signs here. Same type of process on the other side. Here are my parentheses, so that's what I'm going to distribute inside here. The number outside of that is that -2. The 6 is not part of the distributing at all, so it's just going to come straight down. Then I'm going to distribute -2 times anything inside those parentheses. So -2 times x is -2x. -2 times 15 is -30. And now my parentheses are gone, and I can move on to my next step. Step 2 is to combine like terms. Remember that like terms have exactly the same variable or no variable at all. And remember, when I'm working with this, I can only combine like terms that are on the same side of the equal sign. So I'm going to look at each of these sides and see if there's anything I can do to simplify. So on my left side, I have a 5x, a -1x, and an 18. 5x and -1x both have x's, so those are like terms. And I can combine those by adding the numbers in the front. 5 plus -1 is 4, and then x just comes along. 18 is just a plain number. It's called a constant. There are no other plain numbers on this side of the equal sign. Now, there's a number over here, and there's a number over here, but because they're on opposite sides of the equal sign, I cannot put those together. So plus 18 is just going to come down. I'm going to repeat that process over here on the right side. 6 can be combined with -30. I like to do my variables first, so I'm going to look at -2x. There's no other x's, so I'm going to bring down -2x. But it's okay if you put your constants first too. So 6 and -30 can go together. 6 plus -30 is -24. Okay. One really quick disclaimer, actually 2 really quick disclaimers. Firstly, please make sure you're checking your calculations in a calculator as you work. It's very easy to say, oh, 6 minus 30 is -36, but that's not true. So make sure you're checking your calculations as you go so that you're not going to run into trouble later. The second disclaimer is there are many different ways to solve equations. So while I'm giving you a roadmap of steps to follow to work through these equations, and that roadmap will work for you for any problem that you should see, there are different ways to solve this. So if you do it a little bit differently, or if you see somebody else online did it differently, it's not necessarily wrong. There's just different ways to approach this. So back to our problem. Now I've combined my like terms. I put my x's together here to get 4x. I put my constants together here to get -24. So now I have 2 terms on each side. This is where we start to differ just a tiny bit from what we've done previously. So now I have an x over here and an x over here. And previously, I was trying to get that variable term alone. Well, before I do that, I need to move all my variables to the same side. And I'm going to do that using inverse operations. And my little trick to you will be to move the term that has the smallest coefficient. The coefficient is the number in front of the variable. So if I'm looking at this, I have 4x on this side, I have negative 2x on this side. In my mind, negative 2x is the least, so that's the one that I'm going to want to move. Now, this gets a little tricky because I do need to use inverse operations. So I want to move my negative 2x, and I want to move it so that it's over here on this side with this x. I'm going to use inverse operations to do that. So right now, this is a negative 2x, so I'm going to undo that by adding 2x right underneath. Okay? So when I calculate this, negative 2 plus 2, those are going to reduce to 0. Okay? But remember that anything I do to one side, I have to do to the other side. So if I'm going to add 2x's over here, I have to make sure I'm going to add 2x's on this side also. Now, just like combining like terms, all I have to do is add the coefficients here. 4 plus 2 gives me 6 x's. Okay? I haven't done anything to 18, so 18 is just going to come down. My 2x's or my negative 2x's are going to reduce to 0. I don't need to write them at all. And then equals negative 24. Again, I didn't do anything to it. It's just going to come down. Now, from here, it's the same process we've been practicing. From here, I'm going to add or subtract. So that my variable term is by itself. Okay, so now that all my variables are on one side, I can focus on getting that by itself. So 6x is my variable term. Remember, your variable term is your variable and anything that's connected to it. So x is my variable, 6 is connected to that, so 6x is my term. And right now that is not by itself on one side of the equation. Right now, this positive 18 is keeping that from being alone. So I'm going to subtract, remember we use inverse operations, 18 on both sides to get rid of it. I haven't done anything at all to 6x, so it's just going to come down. My 18 and my negative 18 are going to reduce to 0. They're going to go away. And then negative 24 minus 18, I'm just going to calculate that the same way I would anything else. Negative 24 minus 18 equals negative 42. Okay, and you can check that in Desmos if you want. I just type it the way I see it. Negative 24 minus 18 gives me negative 42 right here. Okay. And then finally, just like before, I want to get my variable alone. So I'm going to multiply or divide to isolate my variable. In my first example, my variable is x. It is not currently by itself because that 6 is there. So I'm going to get rid of that 6. Right now that's 6 times x. I don't want 6 times x. I want just x. So I'm going to undo that multiplying by 6 by dividing by 6 on both sides. My 6's here are going to reduce to 1, so x is left over. Negative 42 divided by 6 is negative 7. So I get x equals, negative 7. Now, regardless of how complicated these get, I can always check them by plugging my variable back into my original equation. So I'm going to show you what that looks like really quickly, just so that you can see. So I'm going to start with my original equation, 5x. Remember, I'm going to put parentheses there so that when I plug in my x, it stays by itself. Minus, parentheses, x, minus 18, close the parentheses, equals 6 minus 2, parentheses, x gets its own parentheses, plus 15. And then I just plug in what I think x is. So I found that x was negative 7. So anywhere I had an x, I'm going to make sure I plug in that negative 7 with those parentheses. So one here and one here. Now that I've done that plugging in, I can check this with Desmos. And all I'm going to do is I'm going to ask myself, do these two sides equal one another? Come on. No, we want to be purple today. That's fine. So on one side, I have all of this. So I'm going to type that into Desmos exactly how I see it. 5 parentheses negative 7, close it, minus parentheses again for my negative 7, minus 18, and close it. And on that side, all of this equals negative 10. So the question is, does this side also equal that? And I'm going to do that in Desmos the exact same way I just did. 6 minus 2 parentheses, another parentheses for my negative 7, plus 15, and close it. And I do get negative 10 over here. If my two sides are equal, that means my solution is correct and I did this right. So I'm not going to show you in these notes how to check this every time, but you should be checking your answers to make sure that you're doing this correctly. This is a great way to check your answers before you submit them on a test or on a quiz. And it's a good way to make sure that you haven't made any mistakes. So let's look at the second example here. Remember that we're going to follow those steps in order. Before I told you you could don't call after midnight to remember, but you could do don't call me after midnight. And sometimes it helps to just write this little acronym off to the side. So my D represents my first step, which is to distribute. I only have to distribute if I have parentheses, but in this case I have 2 sets of parentheses, so I'm going to distribute twice, just like over here. In my first set, I've got 8 times all of this, so 8 times y is 8y. 8 times 4 is 32. And I'm going to repeat for the second set. Negative 2 times y is negative 2y. Negative 2 times negative 1 is positive 2. No distributing to do on this side, but I do need to bring down 70 minus 3y. So I've done distributing. Next, I want to combine like terms on the same sides of the equal sign. So I'm going to look at this side first. I like to start with my variables. So I have 8y and negative 2y. Remember, I'm going to combine those just by adding the numbers in the front. 8 plus negative 2 is 6y. And then I also have a constant in 32, and I have a constant in positive 2. Again, I'm going to combine those by adding them together. 32 plus 2 is 34. On my other side, I have a 70 and a negative 3y. Though neither of those is the same, they don't match anything, so they can just come down. Remember, I cannot combine across the equal sign, so even though I have a constant and a constant and a constant, I can't put the 70 over here with my 32 and my 2. So I've combined like terms. Now I'm going to move all my variables to the same side, and I like to move whatever one has the lowest or the smallest or the least coefficient. So I've got 6 on this side, negative 3 on this side, negative 3 is my smaller, so I'm going to move that one. Negative 3y can be moved by doing the opposite. So I'm going to add 3y. Not sure why my colors aren't working. There we go. My negative 3y and my positive 3y are going to reduce to 0. That's the whole reason I'm doing it. But if I add 3y over here, I have to do the same thing over here. I'm going to add 3y's over here as well. Okay. So I'm going to do this just like I combine like terms. 6y plus 3y, 6 plus 3 is 9. Y's come along. I didn't do anything to positive 34, so it's just going to come down. I didn't do anything to 70, so that comes down. And my 3y's have reduced to 0. So I'm done moving my variables. They're all on the same side now, so I can just solve the way I've been solving. I need to add or subtract to get my variable term by itself. My variable term is 9y. Well, now we want to stay purple. 9y is not by itself right now. I've got that plus 34, so I'm going to get rid of it by subtracting 34 on both sides. 9y, I didn't do anything to it at all, so it just comes down. My 34s are going to reduce to 0. 70 minus 34. Again, please make sure you're checking your calculations. It just wants me to draw all over here. There we go. 70 minus 34 gives me 36 on this side. Okay, so I added or subtracted to get my variable term alone. And the very last thing I need to do is multiply or divide to get my variable alone. Y is my variable. It's currently not alone because it's 9 times y, so I'm going to undo that by dividing by 9 on both sides. My 9s are going to reduce to 1, so y is left over. 36 divided by 9 gives me 4. Again, you can check this by plugging it back in, just like we did in the first example. All right, so most of that should be the same as if you're working with variables just on one side. The only thing that's different is that you do need to move all your variables to the same side. So I'm going to do 2 quick examples, and then I'm going to let you practice this a little on your own. So normally we're going to follow that don't call me after midnight. Remember, if you get to a step that you don't need to do or that you can't do, just move on. Now, number 1 is scary looking. Okay, it looks a lot different than what we've seen before. Let me move this down here. At least it feels that way. But you have seen problems like this in the past. In 7th grade, 8th grade, you worked on problems like this. 2 over 3 equals x over 6. And you cross-multiplied and divided to get that variable alone. 3 times x is 3x, 2 times 6 is 12, and then we divide by 3, and x equals 4. Okay, that's something that we've done for a couple of years now. We just haven't practiced it a lot. When you have big, scary proportions like this, where a fraction is equal to a fraction, you're still approaching it the same way. So when you have a proportion, a fraction equal to a fraction, you are going to cross multiply. And that's exactly what it sounds like. I'm going to multiply in a cross fashion. So I'm going to start with the bottom number of 1, and I'm going to multiply that by the top of the other, that whole thing. Now, you don't have to do that right now. So 15 times 6b plus 2. And then I'm going to do the same thing on the other side. I'm going to do 10 times all of that. Again, you don't have to do the calculations right now, just write it out. 10 times all of this for b plus 7. Now that I've written it this way, it looks exactly like the problems we've been working on. So I'm going to follow that don't call me after midnight to go through and solve this. So the d reminds me that I need to distribute. I have parentheses here and parentheses here. So 15 times 6v is 90v. Just because this has big numbers does not make it any scarier. The process is exactly the same. Just make sure that you're using a calculator or Desmos to check your work. 15 times positive 2 is 30 equals 10 times 4v is 40v, and 10 times 7 equals 70. So I distributed. Next, I want to combine like terms. So I'm going to check over here on the left. I have a v and a constant. I can't combine either of those, so that's going to stay the way it is. On the right side, I've got a v and a constant. I can't combine either of those, so that's going to stay the way it is. Even though I have a v over here and a v over here, or a constant over here and a constant over here, they're not on the same side, so I can't combine them in this step. I don't have anything to combine here. I don't have anything to combine here, but I did check it, so I can move on. M tells me to move all my variables to the same side. I like to move the variable with the smaller coefficient. This one has a coefficient of 90, the number in the front. This one has a coefficient of 40, so I'm going to move that one. Remember, like I said before, there are various ways to solve this, and there's different steps, and you can take different approaches, but this is the way that I like to do it. If you really want to move 90V to the other side, go for it. I just like to move the one that's smaller. So 40V is positive right now, so I'm going to get rid of it by doing minus 40V. If I do it on one side, I have to do it on the other side. 90V minus 40V is 50V plus 30. Nothing happened to that. I didn't do anything to it, so I just bring it straight down. My 40V and my minus 40V, or my negative 40V, are going to reduce to 0, so they go away completely. And then my 70, just like my 30, nothing happened to it. It just comes down. So I'm done moving my variables. Now that they're all on the same side, I'm going to add or subtract to get my variable term by itself. So my variable is V. My variable term is everything connected to that, so 50V. 50V is not currently by itself. I have a plus 30, so I'm going to subtract 30 to get rid of that. 50V comes down. My 30s disappear. They reduce to 0. 70 minus 30 is 40. Now that my variable term is alone, I want my variable to be alone. V is my variable. I get it by itself by getting rid of this 50. This is 50 times V, so I'm going to divide by 50 to get rid of it. Anything I do to one side, I have to do to both sides. So my 50s are going to reduce to 1. Those go away, and V is left over. 40 divided by 50. When I do that in my calculator or in Desmos, 40 divided by 50 gives me 0.8. Now, some of you panic as soon as you see a decimal. That doesn't necessarily mean that you've done this incorrectly. Okay, I get 0.8, or if you like to keep it as a fraction like I do, remember that you can press this little button right here, and it will turn it into a fraction for you. So 0.8 as a fraction is 4/5. Now, just because you got a fraction doesn't mean that you did this incorrectly. Remember that you can always plug it back into the original and see if it makes sense. Okay, in this case, it will work. My answer here is 4/5. Okay, so even though the setup looks weird and I need to do that little step of cross multiplying, once I've done that, I'm going to solve this the same way. So quickly, I'm going to work through number 2. Again, I'm following don't call me after midnight. You definitely don't have to write this out every time you do a problem, but I find it helps keep me on track in terms of the steps that I'm doing. So D stands for distribute. I know I have to distribute here because I have parentheses here and here. 10 minus 5x stays the same. 3 times x is 3x. 3 times 2 is 6. And that 6 is positive, so it's going to be 3x plus 6. Then I distribute again. Negative 4 times x is negative 4x. Negative 4 times negative 5 is positive 20. Done distributing. I'm going to combine like terms. On this side, I've got a constant, 10. I've got an x term, negative 5x. Neither of those can be combined with one another, so I'm just going to bring them down. On the other side, I have a 3x and a negative 4x. Those can be combined. 3 plus negative 4 is negative 1x. Also, my 6 and my 20 are both constants. Those can be combined as like terms. So 6 plus 20 is 26. Done combining like terms. M stands for move all your variables to the same side. In this case, I have variables over here and over here. I'm going to switch it up a little bit on this one. So remember, I said I like to move the one with the least coefficient. Well, negative 5x, negative 5 is the coefficient. Negative 1x, negative 1 is the coefficient. Of those two, negative 5 is actually smaller. Think about a number line. It's all the way down on the left-hand side. So it's actually smaller than negative 1. So I'm going to move this negative 5x over here to this side. If you would like to move negative 1x instead, you are more than welcome to. So I have a negative 5x. I'm going to undo that by adding 5x. And anything I do to one side, I have to do to the other side. 10 isn't changing at all, so it's just going to come down. My negative 5x and my positive 5x are going to reduce to 0. Negative 1 plus 5. Again, make sure you're doing these calculations in your calculator or on Desmos. Negative 1 plus 5 is 4. So I get 4x plus 26. I didn't do anything to it. I didn't change it in any way, so it just comes straight down. Now all my variables are on the same side, and I'm done with that step. I'm going to add or subtract to get my variables term alone. My variable term is 4x, so I'm going to subtract 26. 10 minus 26 is negative 16. Nothing happened to 4x, it's just going to come straight down. And then 26 minus 26 reduces to 0, and that goes away completely. Last and final step is to get my variable alone. My variable is x. So I'm going to get rid of 4 by dividing by 4 on both sides. Negative 16 divided by 4 is negative 4. My 4's are going to reduce to 1, and my x is left over. Okay, so with this in mind, I want you to try a couple of practice problems. There's only 4 here. So I want you to do 3, 4, 5, and 6 really quickly on your paper. Do the best you can do, show your work, and then come back here and check your answers with my answers. All right, so check your answers. Number 3, you should have gotten negative 6. Number 4, you should have gotten 2. Number 5, remember that you need to cross multiply that, so it needs to be 2 times all of this, 2 times negative 6 plus 3y. 3 times all of this, 3 times y minus 5. And then you just solve it the same way you have been. You should get negative 1 as your answer there. Number 6, same process. Remember that negative 16 is not part of your distributing, so it just comes down to start with. Okay. The last little thing we need to touch on is what we call special solutions. So the ones that we've done so far have all had one solution. I follow my process and I work out distributing, I work out combining like terms, I move all my variables to the same side. I get my variable term alone. And then I get my variable alone. Okay, the ones like that give you one solution. X is a number, X is 5, or X is 12, or X is negative 4. You get one singular answer. Those are what we call one solution problems. The only number that makes this equation true is if X is negative 4. If I plug in any other number, I'm not going to get the correct answer, or I'm not going to get a true statement. Okay, that kind of ties into what we've been doing with checking our work. If I plug in negative 4, I get a true statement. If I plug in anything else, I'm not going to get a true statement. So when I have one number at the end, a variable equals a number, I have one solution. But we also have some other special solutions. Now, you're not going to know that these are special solutions when you see them on a test or on a worksheet or on some practice. So I'm going to approach this the same way I have been. I'm still going to follow my don't call me after midnight as I solve through this. So I'm going to put it up here. Okay. So when I get to this problem, I'm going to do distribute. 4 times x is 4x. 4 times 3 is 12. and everything else comes down. I'm going to combine like terms. On this side, I have 7x and negative 3x, so I get 4x minus 9. On this side, my 12 and my 1 can be combined, so I get 4x plus 13. Done with that. And then I need to move my variables to the same side. I like to move whatever one is smaller. What you'll start to notice about this is I have a 4x over here and a 4x over there. Neither of those is smaller, so it doesn't really matter which one you move. So I'm going to subtract 4x to get rid of that one. If I do it on this side, I have to do it on this side. Now, 4x minus 4x is 0. That cancels out. It reduces to 0 and goes away. Negative 9 hasn't changed at all. It just comes down. Same as we've been doing. But then I get 4x and negative 4x. Again, those are going to reduce to 0, so they go away. And my plus 13 comes down. Now, there's nothing else for me to do. My next step would be to add or subtract to get my variable term by itself. But my variable terms all went away. So here is where you start to notice that this is going to be a special solution. So what you're going to notice is that all variables disappear. When I tried to move my 4x over, it got rid of my other 4x. All of my variables have gone, and now I just have a number equals a number. So this is going to be either no solution or infinite solutions. And the way that we determine that is whether our final equation that we get is true. So I got negative 9 equals 13. Well, I know negative 9 does not equal 13. That is false. There is no world that we know of in which negative 9 and 13 are equal to one another. There will never be a number that will make that true. So this is what we call no solution. There is no possible number that I could plug in that would make this equation true. I could try numbers all day long and I will never find one. So if all your variables disappear and you end up with a false statement like negative 9 equals 13, your answer is not x equals negative 4. It's not x equals whatever. Your answer, when all of your variables disappear and you get a false equation, your answer is no solution. You can write NS. You can do the null set. It's a circle with this little flash through it. I don't care. But you have to tell me that there is no solution for this problem. Okay? The other kind of solution is what we call infinite solutions. Again, you don't know that this is going to be a special case when you first start working on it. So I'm going to start working on it the same way I would with anything else. I'm going to distribute. When I'm done distributing, I'm going to combine like terms. My 2x and my negative 8x are like terms. They can be combined. 2 plus negative 8 is 6, negative 6 plus 10. Then I'm going to move my variables over. Negative 6x, I'm going to add 6x. Add 6x. Well, negative 6x plus 6x, those reduce to 0 and go away. So 10 is left over. Negative 6x plus 6x, those reduce to 0 and go away. 10 is left over. And I notice at this point that all of my variables have disappeared. They have all reduced to 0. They're all gone. So I know that I'm going to have a special solution of some kind. The way that I determine is it infinite solutions or is it no solutions like we just talked about is to look at the equation. 10 equals 10. 10 is always going to be equal to 10. This is a true statement. because no matter what number I plug in here, it is always going to be true. I am always going to end up with something equal to itself. 10 will always equal 10. So this one is called infinite solutions. You can do IS, you can do all real numbers. We've talked about that a little bit. You can do the infinity symbol. It looks like an 8 squiggled on its side. I don't care how you represent this. You have to represent that there are infinitely many solutions. Every possible number will work for this. All right. Now, I know that was a lot all at once, but I want you to do some practicing. I want you to do 7, 8, 9, 10, 11, and 12 on your own. You don't have to do it right this second, but you can come back and check your answers against mine here in just a little bit. At the top, I've got a quick little reminder of don't call me after midnight, the steps to take to solve, and then a little reminder about special solutions. Okay, so with that in mind, go ahead and complete. Let's do 7, 8, 9, and 10 first. Go ahead and try those, and then come back here and check your answers against my answers. All right, 7 and 8, there was not a lot of simplifying to do. You didn't have to distribute, there's no parentheses. There was nothing to combine on either side there. So we can roll right into moving our variables. So for those, you should have gotten y equals 10 for number 7 and x equals -1 for number 8. Again, it doesn't matter if you moved your 8x here or if you moved your 6x. If you want to add 6x to both sides, it's going to be fine. You're just going to end up with 14 equals 12 minus 2x, and then you continue to solve the same way you would before. Okay. Regardless of how you do it, you should get x equals -1. For number 9, again, I just solve it the way that I'm used to, except right here when I move my variables, I notice that all of my variables disappear. So this is a special case. It's going to be infinite solutions or no solutions. In this case, I end up with 6 equals 6, so that's going to be infinite solutions because it's a true statement. Number 10, I just have to cross multiply. 4 times all of this right here. 2 times all of this right here. And then I just distribute. 4 times 5 is 20. 4 times -x is -4x. 2 times 3x is 6x. Okay. You should have gotten 2 equals x for that one. All right, now that you're all warmed up, let's do the last two, number 11 and number 12. Show your work on your paper. Come check your answers against mine. All right, finally for number 11 and 12, be careful with number 11. Make sure you're watching your signs. When you get through this, you should notice that when you move your -12x from one side to the other, all of your variables disappear. I'm left with -5 and 5. Be careful. -5 does not equal 5. -5 and 5 are not the same thing. Just because they have the same number value does not mean that they are the same. -5 and +5 are different. So this is false, and thus it is no solution. There is never any number that will make this equation true. So you can either write out no solution, you can do NS, you can do that null set, the circle with the line through it. I don't care, but you have to tell me that there are no solutions or no answers to this problem. Number 12 is pretty straightforward. I'm just going to distribute and then work through the rest of the problem, and you should get -4 equals x as your answer. I know that this was a super long video. I really appreciate you sticking with me through this. If you have any other questions, make sure you write them down and bring them to class, and I'll see you then.